So we will discuss how to write a test bench, and we will start with our behavioral modeling. How to write a TB. So this will be a brief discussion about how to write a TB for combinational as well as sequential circuits. Combinational and sequential circuits. So first we will discuss about combinational circuits. So if we have a design in this model, we will have some input ports followed by some output ports, and here we will have our logic followed by end module. So whether the design may be combinational or sequential, here no problem. Here whether the design may be a combinational. Wait a minute. Yeah. So whether the design may be combinational or sequential, we can write the test bench easily for that. So first we should identify the input ports and output ports. We will declare the input ports as reg. So initially in the test bench, we will declare all the input ports as reg and output ports as wire. So we will declare this input and output ports as reg and output ports are wire. And we will instantiate our design with our test bench. Instantiate. So we have already discussed in instantiation, we have two types of instantiations. One is name based instantiation and another is positional based instantiation. So by using any of this technique, we can instantiate our TB with our design. So we can instantiate our TB with design by using this two instantiation methods. And coming to the next step, we will initialize all our inputs. That is the variables which we have declared as regs, we will initialize all of them. So within an initial beginning block, we will initialize the inputs. Generally this is preferred because by default the value of the inputs or the value of our reg will be unknown. So when we initialize our inputs or this regs to 0, then it will be some known value so that we can proceed further. So we will initialize all our inputs. And coming to the next step, in combinational circuits, we don't have any clock. So we will not generate any clock. Whereas in sequential circuits, we will be having clock. So we will generate the clock. We should generate the clock. So according to the design requirement, we will generate the clock. We will set the time period of the clock. Say suppose if we want 10 nanoseconds clock, then we haven't discussed this time scale topic yet. So using this time scale, we will set the time scale of the test bench. So by default, it will be 1 nanosecond by 1 picosecond. The time scale of the design will be or the file will be 1 nanosecond by 1 picosecond. So for generation of the clock, we can use forever. Forever also we have not yet discussed. We have discussed always. So by using forever or always block, we can generate our clock. So if suppose we want to generate a 10 nanoseconds clock, so by using this always block, I will generate a clock always #5. For 5 time units, clock will be equal to 1 and another 5 time units, clock will be equal to 0. So like this, I will generate my clock. Generation of clock. So after this, if it is a combinational circuit, then there is no need to generate a clock, and if it is a sequential circuit, and if the circuit consists a clock in it, or the design consists of a clock in it, then we will generate this clock in the test bench and we will provide it to the design. If the design does not contain any clock, then there is no need to generate any clock. And coming to again, within an initial beginning block, we will drive the input stimulus, drive the inputs. For suppose if we have a full adder, then the inputs for our full adder will be A, B, C in. So we will drive different scenarios like A is equal to 0, B is equal to 0, and C is equal to 0, and we will test for this. Or we can generate A is equal to 0, B is equal to 1, and C is equal to 0. Or also we can generate A is equal to 1, B is equal to 1, and C is equal to 1. Like this, we can generate multiple scenarios and we can drive it to the design. Like this, we will generate some stimulus in the test bench and we will drive it to the design. So this is how we can drive the stimulus to the design. And also we have tasks. So using this task based test bench, we can generate the stimulus and we can drive it to the design. We will discuss this task based test bench in our upcoming sessions. So for now, remember this, we can directly drive the inputs to our design, or else we can use the task to drive the stimulus. If we have a sequential circuit, like say SR flip-flop, then for this flip-flop, we will generate a clock and we will drive it through the test bench. So this is the test bench. So we will generate a clock and we will drive the clock to the SR flip-flop, and we will drive the S, and we also drive the R. So we will drive S and R, and we can capture the outputs Q and Q bar in our test bench. And if we want to display, we can use the $display statements and $monitor statements for displaying the outputs. And also we can display the inputs and we can check the inputs and outputs. So this is the general method or the way we can write our test bench for testing our design. So is this clear? Is there any doubt in here?
No.
Yeah. So now we will start with our topic. So up to previous session, we have discussed about blocking assignments and non-blocking assignments. So we will, in this session, we will discuss about two types of delays in our behavioral modeling. So first type of delay is inter-assignment delay, and the second type of delay is intra-assignment delay. So there are two types of delays in our behavioral modeling. One is inter-assignment delay and another is intra-assignment delay. Now we will see about what is inter-assignment delay. Say suppose if we declare some variables and within an initial beginning block, I'm not writing an entire code. We have declared some 3 registers ABC. We have declared some 3 registers ABC in our module. So now I'm giving, first I will use the case of blocking. So I'm taking the first case where I'm using only blocking assignments. So in this case, I am taking only blocking assignments. So I am allocating the value of A is equal to 0. So for giving inter-assignment delay, we will mention the delay before the variable. Hash say 2, B is equal to 1. So this is the inter-assignment delay. The delay is mentioned before the, sorry, the delay is mentioned in the LHS, or it is mentioned before the LHS variable, like this. So this is the inter assignment delay. Inter assignment delay. Here the delay is mentioned in the LHS side before the variable, and I can assign like this also. Hash for C is equal to, wait a minute, hash for C, sorry, hash for C is equal to 1. Wait a minute, I will take a fresh page. So within an initial beginning block, I'm using only blocking statements. So in this case, I will use only blocking. So I'm mentioning the delay before the variable b is equal to 1, and I can also assign like this hash 5, and in the next line I can assign c is equal to 0. So this is also an intra assignment delay. So this is also an, sorry, wait a minute. So this is also an inter assignment delay. So the delay is mentioned before the variable. We can also mention before the LHS, or we can also mention before this assignment. So this is the case of blocking assignment, where I am using inter assignment delay. Inter assignment delay. So this is a syntax for inter assignment delay. So let us spread the output what we are getting. So at 0 time units, we are getting the value of a is equal to 0. So at 0 time units only, we are getting the value of a is equal to 0, and we are using a blocking statement. Now at after 1 time units, we will get, so after 1 time unit, we will get the value of b is equal to 1. So we will, at 1 time unit, we will get the value of b is equal to 1, and at 6 time units, we will get the value of c, which is equal to 0. Here 1 plus 5, which is equal to 6. So at 6 time units, we will get the value of c. So this is inter assignment delay, and we are taking the case of blocking assignments. Is it okay, right? Is it clear? Now I'm going to take the next case, which is non-blocking assignments, and I will take inter assignment delay only. So within an initial begin block, initial begin end, I will assign a is equal to 0. So this is non-blocking, and I will use inter assignment delay, b is equal to 1, and hash 10 c is equal to 1. So I'm using inter assignment delay and non-blocking. So here the output, let us guess the output. So at 0 time unit, we are getting the value of a, which is equal to 0, and at 5 time units, we are getting the value of b, which is equal to 1, and at 10 time units, we are getting the value of c, sorry, at 15 time units, we are getting the value of c, which is equal to 1. So at 0 time unit, we are getting the value of a is equal to 0. 5 time units, we are getting the value of b is equal to 1. And at 15 time units, we are getting the value of c is equal to 1. So in case of non-blocking assignments and inter-assignment delay, at 0 time units, we will get the value of a is equal to 0, and after 5 time units, we will get the value of b is equal to 1, and after 5 plus 10 time units, we will get the value of c is equal to 1. So this is clear?
Yes.
Now we will see one more example using inter assignment delay. Now I am using inter assignment delay with non-blocking assignments NBA. So within an initial beginning block, I will use A is equal to 0, B is equal to hash phi 1, and C is equal to hash 2 0. So I'm using an inter assignment delay with non-blocking assignments. So in case of inter assignment delay, the delay is mentioned on the RHS side. Here the delay is mentioned on the RHS side before the number. So or the variable. So here the delay is mentioned on the RHS side. Whereas in case of intra assignment delay, the delay is mentioned on the LHS side. Whereas here the delay is mentioned on the RHS side. So here what is our output? So coming to our output, so at 0 time units, we will get the value of A is equal to 0. And in case of inter assignment delay also, I am getting the value of A is equal to 0 at 0 time units only. And here in case of intra assignment delay, I am getting the value of B is equal to 1 at 5 time units. But here in the case of intra assignment delay, I will get the value of, so at 2 nanoseconds only, I will get the value of B is equal to, sorry, C is equal to 0. Or else I will use the same delay which is used in the above example. So I have mentioned 10. Okay, for now I will use 2 only. Next I will change it. So for now it is 2 only. So at 2 time units only, I will get the value of C is equal to 0. And after 5 time units, I will get the value of B is equal to 1. So see the difference here. So in the case of inter assignment delay, what happening is at 0 time unit only, what happens when we declare any inter assignment delay, what happens is at 0 time unit only, the RHS value is evaluated. RHS value is evaluated and it is stored in an internal register. It is stored in an internal register, and after completing the delay, mentioned delay, it will be assigned to the LHS. So after completing the delay mentioned, the value will be sent from register to LHS. So here what happening at 0 time units only, 0 will be stored in some internal register and 1 will be stored in some internal register, and here 0 will be stored in some internal register at 0 time units only. So at 0 time units only, the value is getting from register to LHS A. So at 0 time units only, we are getting the value of A. And after 2 time units, the value which is stored inside the register will be assigned to C. So at 2 time units only, we are getting the value of C is equal to 0. And after 5 time units, the value which is stored in the register will be assigned to our variable B. So after 5 time units, we are getting the value of B. So is this clear? So is this example clear?
Yes.
So I will give one more example comparing both intra and inter assignment delay. So this is inter assignment delay and this is intra assignment delay, and I'm taking both non-blocking only. So within initial begin, I will take a is equal to 0, and here also a is equal to 0 within an initial beginning block. And now b is equal to, so this is an inter assignment delay, so b, so after one time unit I will allocate b is equal to 1, same delay value, but I am taking intra assignment delay, b hash 1 1, and here I will allocate c is equal to 0, and here also I will allocate c is equal to 0. So let us analyze the outputs here. So at 0 time unit, what I will get, a is equal to 0, and here at 0 time unit I will get a is equal to 0 and c is equal to 0. Here I will get both the values, a is equal to 0 and c is equal to 0. Whereas in case of inter assignment delay, here the delay 1 is present. So after completing this delay only, the assignment, the whole assignment will be happened. That is b is equal to 1 and c is equal to 1. Whereas here there is intra assignment delay specified. So after completing this assignment, the value which is stored in our internal register will be given to b. It is not blocking the entire assignment here. It is just stopping the assignment to our variable b. So that's why we are getting at 0 time unit a is equal to 0 as well as c is equal to 0, but here we are getting a is equal to 0 only. So at 1 time unit we will get b is equal to 1 and c is equal to 0, and here at 1 time unit we will get the value of b is equal to 1. So this is the difference between the inter and intra assignment delay. So in the case of inter assignment delay, after completing the delay only the assignment is happening, whereas in case of intra assignment delay, after completing the delay, the value which is stored in our internal register is getting assigned to our variable. It is not blocking the assignment. So is it clear? So this is where we get confused most of the times. So this is the difference between the inter and intra assignments delays. So is it clear? If you are having any doubt, you can ask me.
Yes, clear.
Yeah. And we also, now we will take one more scenario with the blocking assignments. So initial begin a is equal to 1 hash 5 b is equal to 0 and hash 10 c is equal to 1, ending this. And here also initial begin a is equal to 1 and sorry, this is intra assignment delay, so b is equal to hash 5 0 and c is equal to hash 10 1, and ending this. So I'm using blocking statements and I'm comparing inter and intra assignment delays. So at here on the LHS at 0 time units we will get the value of a is equal to 1. So at 0 time units only we will get the value of a is equal to 1, and here we are using blocking assignments. So this assignment will block the next assignment. So at 0 time unit we will get only, or else we will take the previous scenario only. So here the delay is 1 and here I'm not taking any delay, and here the delay is 1 and I'm not taking the delay at all. We will see the previous example only. with the blocking assignments. So here, in case of inter assignment delay, at 0 time units, I will get the value of a is equal to 1. And here on the right hand side, at 0 time units, same, I will get only the value of a is equal to 1. But in case of non-blocking, I am getting the value of a is equal to 0 and c is equal to 0 at 0 time units only. But here at 0 time units, I will get only the value of a. Since this here I am using blocking assignment, it will block the next assignment. So at 0 time unit, I will get only a is equal to 1. Is it clear? And at 1 time unit, we will get the value of b is equal to 0. Here also at, I'm sorry, sorry, I got confused. So within an initial beginning block, I'm using blocking statements and I'm using inter assignment delay. So b is equal to 1 and c is equal to 0, ending this. And within an initial beginning block, begin, I'm taking a non-blocking 0, sorry, blocking, b hash 1 1 and c is equal to 0. Sorry, I got confused here. So in case at 0 time unit, on the left, wait a minute. So at 0 time unit, I will get the value of a is equal to 0. And here also at 0 time unit, here the inter assignment delay 1 is mentioned here, so it will block the execution of further statements. But here at 0 time units, we have a is equal to 0 and c is equal to 0. We will get a is equal to 0 and c is equal to 0. So there is no delay that is blocking here. So after completing, so at 0 time units only, we will get a is equal to 0 and b is, c is equal to 0. And after at 1 time unit, we will get the value of b is equal to 1. And on the right hand side, so at 1 time unit, we will get the value of, here c is equal to 0, and at 1 time unit, we will get the value of b is equal to 1. So this is how the inter assignment delay works with blocking assignments. So is it clear? Is it clear, right?
Yes.
So this is how inter and intra assignment delays works with blocking assignments and non-blocking assignments. So we can consider one more scenario here. Wait a minute. Or else I will directly show it in the with the help of simulator. Reg A, reg B, and reg C. And within an initial beginning block, reg, yeah. So within an initial beginning block, first I'll take the case of inter assignment delay with blocking and non-blocking assignments. So within an initial beginning block, I will use a is equal to 0. I will use a blocking, and I'm using an inter assignment delay so I'll use hash 1 b is equal to, I'll use a non-blocking, and I'll use hash 2 c is equal to 0, or else I'll remove this delay. So I've mixed both blocking as well as non-blocking. end this block, and within another initial begin block, I will monitor this. The value of is percentage d at time. So for displaying the time, we will use the argument percentage t comma a comma dollar time. I'll copy this and paste it over here. So the value of a, b, and c. So I've used blocking and non-blocking, and I've used inter-assignment delay. Now let's see what we are getting in the output. Yeah, let me make it as a top model. So in the simulation also we should make it as a top model. Blocking and non-blocking. That's a good example here. So let me run this. Yeah, so let me show you it in the console. See, so the value of a is 0 at time 0, and the value of b is unknown at time 0, and c is unknown at time 0. Let me show the code also at the same time. Where is it? So here what happening is a is equal to 0 at 0 time units, and at 0 time units only b is equal to unknown and c is equal to unknown. Since those are registers, we have not initialized them, we are getting an unknown values. Wait a minute. Is it visible, right? Since we have not initialized them, we are getting as unknown. And again, c is equal to 0 at 1000. So since I have told you already, this is 1 nanosecond by 1 picosecond time scale. So we are getting at 1000 picoseconds. So at 1000 picoseconds or at 1 nanosecond, we will get b is equal to 1 and c is equal to 0. So after completing this delay, we are getting this assignments b is equal to 1 and c is equal to 0. So this is inter assignment delay with mixed assignments, that is blocking and non-blocking. So we can also use blocking entirely. So b is equal to 1, a is equal to 0, b is equal to 1, c is equal to 0. Now let's see what we are getting. So I've used only blocking assignments. A is equal to 0, b is equal to 1, and c is equal to 0. So the output we can see A is equal to 0 at time 0, b is equal to unknown at time 0, c is equal to unknown at time 0, and b is equal to 1 at time 1000 picoseconds, and c is equal to 0 at time 1000 picoseconds. We are getting the same output. So if we use blocking or else non-blocking with inter-assignment delay, we will get the same predict outputs. Now we will change reg m, reg n, and reg o. So we have this. We are taking this three inputs. Sorry, three registers m and o, and within an initial begin and block. Now I'm considering the case of intra assignment delay. With blocking and non-blocking assignments. So I'm making A is equal to 0, and after one time unit, so I'm using intra-assignment delay, so it should be mentioned on RHS side. I will use the blocking with hash 1 and C is also blocking. Let's take a blocking. Yeah. And ending this. So I've taken A is equal to 0, B is equal to hash 1 C is equal to 0. So let's see what we are getting. So, sorry, I've used EBC only here. Okay, so I will change it to MNO. MN and O. So let me copy the displays also. And I'll paste it over here. So M N and O. M N and O. So let's see what we are getting in the output. Launch. So I'm considering the case of intra-assignment delay with blocking and non-blocking assignments. So here we can see the value of M is 0 at time 0. I will open the code also. So initially, wait a minute, I will, okay, no problem. So M is equal to 0 at 0 time units. So M is equal to 0 at 0 time units. And here we can see O is also, O is unknown. Okay, and we can see O is unknown at 0 time units, and N is also unknown at 0 time units, and N is 1 at 1000 picoseconds, or N is 1 after 1 nanosecond, and O is 0 after 1 nanosecond. So sorry, in the theoretical part I have confused. So if we have used blocking assignment with intra assignment delay, so it will block the execution of next. So here this we have used a blocking assignment, so this step is blocking the assignment of this step. So after the assignment of n only, we are getting the value of O. So since we are using a blocking assignment here, so after completing the assignment of n is equal to 1 after 1000 1000 picoseconds, we are getting the value of O. So if we use a non-blocking assignment here, then we will get the value of O at 0 time units only. Let's see. Let's relaunch it. See, the value of O is 0 at 0 time units only. Since we are using a non-blocking statement, this is not blocking the further assignment. But if we use a blocking assignment here, it will block the assignment of, it will block the further execution. When we use a non-blocking, it will not stop the execution of further assignment. So at 0 time unit only, we are getting the value of O at O as 0, and after 1 time unit, we are getting the value of N as 1. So this is how blocking and non-blocking assignments we use with inter and intra assignments delay. So is it clear for everyone? This is very, very important.
Yes, sir, clear.
So we can take one more example, like yeah, this is enough, I think. Okay, take one more example. Hash. I'll use a blocking there. So it should block the further assignment for the execution. So the value of m is 0 at okay. So here we can see, so at 0 time units we are getting the value of m as unknown only. Since we are using an intra assignment delay, so after 2 time units we will get the value of m to 0. So here we can see m is 0 at time 2000 picoseconds. So after 2 time units only the value is getting assigned to m. So before that no value is getting assigned to m. So we are using a blocking assignment here. Here we are using a blocking assignment. So the value is not storing into m, and since we are using a blocking assignment, this simulator is not going into next step also. We are in the first assignment only. So up to 2000 picoseconds we will be in the first assignment step only. So after 2 plus 1, that is 3000 picoseconds, we are going to next step, that is n will be equal to 1. And since here we are using a non-blocking, we will get at the same time the value of O, which is equal to 2000, sorry, 0 at 2000. Since it is non-blocking, so after finishing this m is equal to 0 after at 2000, it will go to step 2, and it is non-blocking at the 2000 only. At 2000 picoseconds time period only we will get the value of O as equal to 0. So this is how we will use the blocking and non-blocking with intra assignment delays. So is it clear?